afternoon, everybody. Welcome to Science Access. Today we'll be dealing with some common fatty acids and their sources, their structure, and nomenclature. Please, if you know that you're new to this channel, kindly like and press the notification button so that you get notified when next we post new videos. Now, the first in our table or in the series is the lauric acid. Lauric acid has 10 carbon atom. Now, here's supposed to be the number of double bonds. Seeing it is 0, that means it is devoid of double bonds, no double bond, all through single bond. And now this is the condensed form of lauric acid. As you can see, the 10, right? CH2 appear 10 times, 10 plus 1, which is 11 plus 1, which is 12. And I told you, saturated fatty acid at the very end two, you have the saturated fatty acid and the unsaturated fatty acids. And now this fatty acid itself contains two parts, which is the carboxylic part and the hydrocarbon part. So now they also act as buffer. Now I told you the source of lauric acid, you have got it from palm kernel oil. Remember palm kernel oil and butter, common source, and as well coconut oil. These are the three sources of lauric acid. And now going with the structure of lauric acid, as you can see displayed on the board, we have the carboxylic head, which is the positive part of the lauric acid, and the 12, right? 12 carbon atom. This dignifies 12 carbon atoms. Now, how can we start our naming, or where will we start our counting? So now remember that this one, the carbon here, has the two OH here. Now, this structure, now seeing this negative sign, don't be confused. This is the protonated form of fatty acid. Maybe this kind of fatty acid is in an aqueous solution. So now, since it is a buffer, when it reacts with water, the proton is precipitated. And now that is why we have the negative sign here. And mind you that our count starts from the functional group, which is the carboxylic head. Now, which is 1, right? Note that every breaking point, there's a carbon atom there. So now we'll note that one. Now, 1, I told you every breaking point. 2, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see? 12. This validates our 12 here. So this is the structure of lauric acid. How do we name this compound under the systematic name or IUPAC naming of this lauric acid? Imagine this is the common name. We have the common name and the IUPAC name. So the IUPAC name of this one, remember our aliphatic or the alkanes, right? Now this is 12, right? Naming this under the IUPAC pattern. Now that 10 is the cane, right? The cane, right? 10 is the cane. And 11 is on the cane. 12 is do the cane. 12 is do the cane. So naming this one now, it will be do-decanoic acid. Do-decanoic acid, please. I'm sorry, no space. D-E-C-A-N-O-I-C. Do-canoic acid. Do-canoic acid. This is the IUPAC naming of the lauric acid. I told you that lauric acid is the common name, as you all know, while the systematic or the IUPAC naming is the do-canoic acid, because we have 12 carbon here. So 12 carbon under the alkane series is the do-decane. So since it's an acid, due to the presence of the carboxylic group, signifies or it is do-canoic acid. So if they ask you any question, what is the IUPAC naming of lauric acid? Is do-decanoic acid. Now move to the second one, which is the myristic acid. Myristic acid, note that it is gotten from nutmeg, coconut oil. So that is the sources. And now the structure of myristic acid. Note that myristic acid have 14 carbon with no double bond. When you see 0 in anything like this compound, know that it is devoid of double bond, no double bond, all through single bond. And now this is the condensed form. As you see, CH3 and CH2, 12, right? So imagine the difference between here is 2, right? Here was 10, right? Now here is 12. Now dealing with the structure, We use the same procedures we used for the first one. This is the carbonic head, and now this is the hydrophobic tail, which is the water heating. Now, we remember we start our counting from the carbon carrying the two oxygen, which is one. That's why I have a 1 year. Now, I told you before that every breaking point con- contains a carbon atom. Now, the first breaking point, 1, 2, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You see, 14, 14. This is the structure of the myristic acid. And so this is the common name. Then the IUPAC name of this fatty acid is called how? How can we name this thing? Mind that I told you before that 12 is decane, right? Now, why 14? Why 13 is tridecane? 14 is tetradecane, right? Now, imputing that knowledge into this one now will give us tetradecanoic acid. Tetra is for, right? Decanoic acid. That is the other name or the IUPAC name of the myristic acid. Now, going to the next one, which is the palmitic acid. Palmitic acid is gotten from palm nut. From palm nut. And it has 16 carbon with no double bond, or two single bond. This is the condensed form of the palmitic acid. You see here, CH3, CH214, COOH. And the sources of this one is all animal and plants that derive from both animals and plants. Note this one, please. And now, after the source, we go straight to the structure. The structure of palmitic acid. Remember that we always start our counting from the functional group, which is the carboxylic head. 1, right? 2, I told you every breaking point, there's a carbon atom there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, you see, which is true, 16. This is the structure of palmitic acid. And I told you this is the common name. Now, they can ask you in an exam or anywhere, maybe in your classroom, what is the other name of palmitic acid? What is the other name of palmitic acid? No, mind you that I told you, the myristic acid which contains 40 carbon atom is called tetradecane, right? No, now 15 will be pentadecane, while 16 will be hexadecane. Implying that knowledge into this one, the other name or the IUPAC name of this one will be hexadecanoic acid. So the IUPAC name or the systemic name of this acid is called hexadecanoic acid. Okay, now note that one. Now the fourth one in the series is the stearic acid. The stearic acid contains 18 carbon with no double bond. Now this is the condensed structure of the stearic acid. And now the source as well got it from all animals and plants. So palmitic and stearic acid are got it from animals and plants. Note that one. And the structure, this is the structure displayed on the board. As you all know, we start our counting from the functional group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. You see, no double bond, all through single bond. And this part contains hydrogens without double bond. So this is the structure of stearic acid. Now, the IUPAC name of stearic acid, okay, as we did for palmitic acid. Palmitic acid, I say that it is hexadecane, right? Now, after hexadecane, 17 is heptadecane, while 18 is octadecane. Now, implying that knowledge into this one, now we have stearic acid is also known as octadecanoic acid. Octadecanoic acid is the IUPAC name or the systemic name of stearic acid. You see, just pay a close look. Remember, I told you it contains 18 carbon atom, right? With the structure in a condensed form, right? Now, this is the expired form. Starting our counting from here, which is this one, the positive head, which is the functional group, naming it towards the side. It must be 18. That is it for stearic acid. Now, for arachidic acid. Arachidic acid contains 20 carbon atom. Arachidic acid contains 20 carbon atom without any double bond at all. This is the condensed form. We have CH3, CH2, 18, COOH. Source, the peanut oil. Note that one. Source of arachidic acid is from peanut oil. After the source, you go to the structure. This is the structure of arachidic acid. Now we start our counting from here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. You see, complete 20, 20. This is the structure of arachidic acid. Note that all these names, the arachidic acid, the stearic acid, the palmitic acid, they are common names. They are common names and systematic names, or the IUPAC name. So the IUPAC name of this one will be, guess the name of this one. See, it is 20 carbon. 20, right? And under the naming, under the IUPAC nomenclature of this one, we have the way the 20 carbon is icosine, right? Now, imply this knowledge to this one. The might note that this arachidic acid is the common name, while the IUPAC name and common name are different. So the IUPAC name is just in deals with the number of carbon present, and we're meant to know that arachidic acid contains 20 carbon atom, and 20 carbon atom in the list is icosane. Now, let's use that knowledge. We have the 20 carbon, which is the icosane, right? Which is the icosa. And the COOH, which is the functional group, is the oic, which will give us eicosanoic acid. But recently, the new name of this acid is now eicosanoic acid. Eicosanoic acid. So this is the name eicosanoic acid. Before it was eicosanoic acid, but now it is now ICOSANOIC. So this is now the validated name for arachidic acid. Now number 6 is the lignoceric acid. Lignoceric acid contains 24 carbon atom with no double bond. The condensed form of the lignoceric acid is displayed here: CH3, CH2, 22 are the subscripts, and COOH as the functional group. The source is from seeds of plants and plant derivatives. Now, the structure as displayed on the board is it contains 24 carbon atom. Start naming from the functional group, which is the carboxylic group 1. Remember, there's a carbon atom here, 1, and every breaking point there's a carbon atom there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now, this is the structure of the lignoceric acid. Now, the IUPAC naming of this compound displayed on the board is, now, using the IUPAC pattern, 24 is tetraicosane. Tetraicosane. Now the acid will be tetra, right? Noic acid. This is the IUPAC name of lignoceric acid. The IUPAC name of nucleic acid is tetracosanoic acid. So this is that for nucleic acid. Now we move to the capric acid. The capric acid contains 10 carbon atoms. The capric acid contains 10 carbon atoms. It is which can also be represented in this condensed pattern, which is CH3, CH2H, COOH. Sources of capric acid. The capric acid can be gotten from coconut oil, can be gotten from milk, goat milk, and cocoa butter. So now, after the source, we go straight to the structure, right? The structure of the capric acid is, remember we started our counting from the first group, which is the COH 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the structure of the capric acid. Now, what is the nomenclature or the IUPAC name of this compound or this acid? Know that 10 is decane. If you are familiar with your IUPAC naming, you should know that 10 is decane. Now, the acid will now be decanoic acid. Easy. Decanoic acid is the IUPAC name or the systematic name of the capric acid. This is the summary of what we did earlier. We have under the saturated fatty acids. Here we have the common names and the systematic names. The first in our list is the capric acid. The capric acid being the common name. Systematic name is the decanoic acid or the cyclic acid. Now, the second here is the lauric acid as the common name, while the systematic name is the decanoic acid. The which is 12 lauric acid, has 12 carbon atoms. The third here is the myristic acid as the common name, while the systematic name is the tetradecanoic acid, because 14. Tetra is 4, right? While the decanoic, which is 10. Now, the fourth here is the palmitic acid. The palmitic acid, also known as the common name, right? Now, while under the systematic name is known as the hexadecanoic acid. The fifth here is the stearic acid on the common names, while under the systematic name is called the octadecanoic acid. Now, we have number 6 here, the arachidic acid. The arachidic acid being the common name, while under the systematic name it is called the eicosanoic acid. So, see, this eicosanoic acid is the old name for this under the systematic names. This name here is the old name. While the current name, if you check the spelling very well, you see that this E is no longer there. So we can leave it like this. It is also correct. Now, number 7, we have the behric acid. The behric acid is also under the common names, right? Now, under the systematic name, it is called the docosanoic acid. The docosanoic acid. While number 8, we have the lignoceric acid as the common name, while under the IUPAC naming or the systematic name, it is called the tetracosanoic acid. Where the last in the series is called this cerotic acid, being the common name, while the systematic or the IUPAC name is called the hexacosanoic acid. So this is for this video. Thank you. Please subscribe to our channel.